balloons are like, they're more fun.
Yeah.
They're gonna pop. You're gonna fall.
All right. It's gonna pop and you're gonna fall. Yeah. Welcome to Walkabout the Galaxy, the spooky astronomy spodcast. A spodcast?
I love spodcasts.
It's a spodcast.
Spodcast. You can listen to it when you're at the spa, maybe when you're getting your nails done.
Yeah.
That is what a spodcast is, and that's totally why I said this. It was not a flub.
Yeah,
it was
right.
a rebranding of
Our
Walkabout the
voices
Galaxy.
are so soothing.
We could do a version.
The soothing sound.
We've talked about doing like an ASMR version. We could also do like a soothing spodcast version.
It's the spodcast. Where the science is universal, the opinions are personal, and the party is just getting started. Well, that doesn't go with a spodcast.
I mean,
really
sometimes you go to a spa
and have kind of
for
a party.
A party.
Or like a bachelorette party.
Okay.
Yeah.
We are Strange Charm, top and down, the Astroquarks, also known as Josh Caldwell.
Addie Dove.
Jim Cooney.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida. Subscribe to us on all platforms, including Facebook, YouTube, Instagram, and Threads. You can contact us anytime at wtg@ucf.edu with questions, suggestions, and compliments. Our Stumper today, I believe we've done something along these lines, but not with Audrey, and I want to revisit it because of some news. This is a financial Stumper.
Ooh.
And one of our space news items has to do with Virgin Galactic. Our friend and colleague, Alan Stern, is listed as an astronaut for the next flight.
020.
020.
Really?
Yeah.
When is that?
Next month. November. Launch window opens early November.
Yep.
Oh, wait, November what?
2023.
No, I know, but early November.
Yes, early November.
Early November.
Like the 2nd or something.
But yeah, an exact date hasn't been settled on at the time that we're taping this. In any event, Alan Stern, PI of the New Horizons mission to Pluto, and
Co-I of the Lucy mission.
And general international man of planetary science.
Yes.
Is going to fly on their next suborbital flight on Spaceship Two. Now, this is a company, they've actually got a rhythm going. They've been doing basically a flight a month for several months now. They have.
Okay.
Yeah, this will be their 6th flight in 6 months.
Okay.
Yeah. And
I don't trust Josh is a liar. Maybe.
And some of those have been paying customers. And, I mean, all of the flights have been paid for, but some of them have been like pure tourist flights. And so they originally sort of started as like, we're going to do tourist flights. We're going to be flying very frequently and selling tickets. And they took a bunch of deposits from people. Initially, they were selling for a cool $250,000. And now they're selling them, I believe, for $400,000 for a seat.
That's
a steal.
And
that's more expensive.
This is a space plane that gets dropped, taken up to like 45,000 feet by this cool mothership that drops it, fires its rocket, and it goes up to about 86 kilometers, I think. Is that right?
Space is that space or not space?
It depends who you're talking to.
Yeah.
So some people say 100 kilometers is space, and some people say 50 miles is space.
Why are you mixing units?
Because this was what people do.
Because
it's like
I didn't
different
do it,
requirements.
Those are different people.
Yeah.
Some
my
people,
God.
Organization.
Some
Well,
people
whoever
use
says
kilometers and
miles
some
is
people
not.
said miles.
I'm not going to listen to them.
Well, they're the ones.
They're the ones.
According to them, this is going into space. According to the 100 kilometers people, it's not quite.
Sounds like it's not quite going to space.
There's lots of different ways you can define space. So it'll be dark and deadly outside, and you'll free float.
Guess that's good enough
a couple of minutes
for near space,
which has nothing to do with space, but rather the trajectory of the vehicle they're on.
Well, and no drag, right? There can't be significant drag, so there's enough of a vacuum there. How much of your so Alan's money? Alan didn't pay for this out of his own bank account.
No,
and so he'll be doing some research projects. The question is, how much money? At what price point do you buy a ticket for one of these rides?
Have to buy it at some point.
at some point, maybe you're like, there's no way in hell I'm going to get on it. I mean, my wife would not.
Yeah.
You would have to pay her a lot for her to do this, right? So it's a negative price.
Yeah.
You know, you can, if you're in the negative realm, go ahead. Say, I would only do that if you give me $10 million or something like that. Jim, are you in the negative price?
No,
realm? 'Cause
no,
I thought you
no.
might be. I
No.
thought of the three of you, you're the one who.
I am the
might be
most
in
likely
price
to be
in
the wimp
negative.
and go in the negative price. No,
You're dark
wanna
matter?
do it, but
You would do it for.
Wimp.
I would do it for
Now you're
$1,000.
okay. And how much would you pay for a Taylor Swift concert ticket?
Ooh.
It costs something like $1,000.
I know.
Yeah.
I would pay $100 for.
What
it.
if Taylor
really?
Swift
Okay,
was
so you would
also...
rather do this
Yeah.
than go to a Taylor Swift concert.
Yeah. Because Taylor
Even though
Swift
the
concert,
Taylor Swift concert will last longer.
it will. It will. But
Yeah.
There's like some training and stuff leading up to it, so...
Yeah.
but that's just, it's so once in a lifetime and so different from any other experience. I've been to
The Taylor
concerts
Swift
before.
concert, you mean?
This is what I've heard. I mean, you know, the Eras tour.
It is an experience.
Right.
Yeah.
Okay, $1,000.
$1,000.
$2,000, like, yeah.
I mean,
It's too rich for my
I just don't make
It's
that much
interesting,
money.
right? Because like the price point...
That's a dig.
It's a,
That's a dig at me
just-
there.
A price point comparison, right, is to do a 0G flight, which is the parabolic flight that lasts like 2 hours and you get like 20 parabolas or something, which are like 30 seconds-ish each of free floating. Those cost about $5,000.
Yeah.
Whoa.
Okay.
So like something on the order of like $5,000 to $10,000 for a suborbital flight,
Would you do it?
I
mean,
would do.
Yeah, because you've flown on the Vomit Comet a bunch, but you haven't had to pay for it, just like Alan is.
I mean, I've had to pay for it. I wrote grants that took a lot of my life and my
Work, right.
energy. But yeah, those are research.
So you would say, what did you say? 10, 20?
10K.
10K, you would do it?
Yeah.
Yeah. Audrey, how about you?
So
It's less than a car.
I was a student a little over a year ago, so my savings is
So let's assume at some
pretty
point
much
you
nothing.
have money.
Okay, so this is in the future when I make an average of what y'all make.
Sure.
Well, an average of what they make. Let's not go crazy.
I was gonna say more, but more than what y'all make.
Probably more than what we make.
But I think like around 5-ish.
$5,000.
Yeah, I think it's hard because like it depends on I don't know. I feel like there's a lot of factors. I would want to do it, especially in this hypothetical world where it is the future and I'm making more money.
Right.
I also assume in this hypothetical world that they've launched a lot more times and it's a lot better and normal and all that good stuff. So like I'm not going to be worried about anything, but it would be like a vacation thing, you know? It wouldn't be something that I would, you know, just be like,
What
okay,
about,
on
like-
Tuesday I'm going to do it. There'd have to be a whole trip around it. It would have to be a whole
Like for
thing.
Okay.
You know.
All right.
I might up mine.
Please
even.
elaborate some more.
Okay. So then also, like, could dogs come? Like, there's a lot of other things.
My follow-up is that
Oh God, there's a follow-up.
There is a follow-up. Another space tourism adventure is the Worldview, which they're selling tickets now. Or they're taking reservations.
This is a large balloon
Right.
that stays up for a while,
Yeah. So
like hours.
yeah, it goes up to 100,000 feet. So here's a new unit of altitude for you. So what's 100,000 feet is 20 miles ish, 18 miles or so.
Higher than airplanes fly.
It is about 3 times higher than a commercial airline flight. And a 2-hour ascent, you hang out up there for 2 to 4 hours, they say, and then a 90-minute descent. And they're planning multiple stations around the world that would be scenic for you to go to. At the moment, they're taking reservations for Grand Canyon and the Great Barrier Reef.
But there already are balloons that go over.
Not 200, not with
Well,
people
yeah, okay.
for a
People
ride.
for
Okay,
these.
they're selling their seats for $50,000. How much would you pay for that ride?
10K.
Same.
Yeah.
Negative 1,000. No interest.
What?
You're more willing to go on the Virgin Galactic rocket than you are on the
that I
balloon.
would that I could say I was in space and it'd be like it's black and
Right.
this is like
I wouldn't be able to see
it's
anything,
just,
so
it's
it'd
just
be cooler.
high. It's just I'd just be
I think it would
afraid
be
of heights, freaked
It's
out,
about-
don't want it.
Like,
It's
I
about
love-
1/3 as high as the peak altitude for the Virgin flight, which goes to about not even 300,000 feet.
No interest. No interest. It's too high.
I really like the idea of a future where these worldview flights are like pretty common, and you can have like fancy corporate event type things and all of that.
There's 8 people, and I think you have like a flight attendant and probably champagne and
cheese,
num-nums and things like that.
It's very like I'm just like Roaring 20s-y kind of. I don't know.
Yeah, sure, yeah, like definitely.
Anyway. What's your number on that one, Audrey? Higher or lower than the rocket?
I think I'd pay more. I'd definitely pay more because the views would be so much cooler.
I think I might.
And balloons are like, they're more fun.
Yeah.
They're gonna pop. You're gonna fall.
All right. It's gonna pop and you're gonna fall. Yeah. I do have an irrational fear of that happening. I have to say.
Is that irrational? I don't know.
I don't know if that's irrational.
Anyway.
You're going to fall for so long.
Yeah.
I mean, you'd black out pretty quickly.
Out quickly at that altitude.
Well, you're in a capsule. The capsule itself is...
Yeah, but if you're dropping that fast, you're probably going to black out pretty quickly.
Yeah, out of fear. The adrenaline is just going to
Maybe you slam your head into the ceiling. I don't know.
I don't know.
You're drunk. You're not wearing a seatbelt up there.
You're so drunk. Everyone else is drunk.
Speaking of scary things, today we'll talk about scary stars, detecting alien life, the density of the universe, and much more. But first, this episode of Walkabout the Galaxy is brought to you by General Relativity. Are you feeling weighed down by all the demands on your time? Kids, work, laundry, bills, and on top of it, you're weighed down by your actual weight. If Newtonian gravity is a drag on your life, trade it in for Einstein's general theory of relativity. Trade that force that's keeping you down in for an elegant theory of the shape of space-time. Instead of getting pulled into the ground, free yourself with the knowledge that you are just following a natural path through curved space-time. Explaining everything from orbits to black holes to time dilation and gravitational lensing, general relativity has been shaping your world for more than 100 years. So drop the force of gravity like a lead brick and embrace your world line through four-dimensional space-time with general relativity, everywhere you want to be.
American Express?
Expedia.
Yeah, I like American Express.
I don't think it's American Express, but I feel like it's like a company.
Yeah.
And it's not American Express because they're actually not very universal.
No, everywhere you want to be is Visa.
Yeah. I think that's the wrong credit card, but I should have just said credit card company.
Insert. You would have won.
I know.
You would have had enough money to pay for one of those flights.
Thanks. I know. Thanks, General Relativity. That when you started saying that, it made me think of commercials for the General. It's like an insurance company.
Oh, yeah. No, maybe I should have looked for their tagline.
You should have.
Yeah. So, as we mentioned, Virgin Galactic flight coming up. Alan Stern will be on board. Other space news of note, SpaceX announced some rather ambitious target numbers for launches in 2024.
They did. One of the things we do yearly on this podcast is
guess the launches.
Guess the launches, and we're up to 74 already this year.
Huh.
Just from SpaceX.
From SpaceX.
Oh, damn.
Yeah. And they're
which is a record for
140 or something next year is what they're trying to do.
I think it was even maybe even 170. It was a
very large number.
This is mostly Starlink or all Starlink?
I mean, mostly.
It's got to mostly be that because I don't think
that's
anybody else
has
are
right now.
Yeah,
many satellites to go.
Yeah.
That's
which is just a crazy amount of launches.
Yeah.
Yeah.
So they launch from both Florida and Vandenberg in California, but that's it for the Falcon 9 launches. I mean, they're trying to get the Super Heavy off from Boca Chica.
Yeah. There was a hearing for Congress this week about a bunch of spaceflight related stuff, and it included some representatives from Virgin Galactic and SpaceX and other companies, and a lot of it is about like what the regulations are. So there's still a lot of FAA regulations, and of course SpaceX is like, you're dragging us down, and not just SpaceX, but like there's just a lot of bureaucracy that makes it hard to do the sort of quick things sometimes that they want to do. But also they like blew up an entire area, so maybe
there's
it's a little slow this time.
Maybe there's a reason for some of that oversight.
So, and there's also this question about like flying humans and spaceflight participants and things like that, and they're sort of in what they call a learning period. So like letting these companies sort of do it without a lot of excessive regulations, and you sort of need that while they figure things out. But also there's some liability, but like they're trying to extend that because everything's taking longer than they thought it would.
Yeah.
So it's interesting.
So a lot of these
interesting times.
services came along a little bit slower than anticipated, which meant certain regulatory periods have expired before they learned as much as they were hoping to learn. Is that right? Yeah.
Yeah.
And, basically now they're sort of like when Alan and company go on that Spaceship Two thing, they'll be sort of signing saying, I understand that this is not like an FAA approved mode of air transport.
Yeah.
and I'm, not holding, anybody responsible for what goes on.
Probably
here.
less paperwork than they had to sign for the Titan.
Yeah, jeez. And then but as you mentioned, the Super Heavy blew up Texas.
Yeah,
and
supposedly they're basically like ready to do some more tests. But
No way.
They're ready to fly again.
They're ready to fly again, but they're waiting on approvals
a
and stuff like
launch
that.
certificate from the FAA.
But they're going to do it differently, right?
Well, hopefully.
Yeah, they made improvements.
So I don't think they have. I don't think they have an interest in doing it the same way.
So, like, for reference, when they were doing...
That's not enough time.
It is. Because when they were doing early testing before Falcon 9, they cut, like, Grasshopper was one of their early test programs, and it's, like, was test flights. They blew up rockets and, like, we're flying next week with modified versions. Like, that's part of what SpaceX does, is they iterate really rapidly, for better or for worse.
Interesting.
Yeah.
Like, they're much more about just, like, fix a small thing, try again, find out what's wrong, as opposed to, like, long integration periods where they're, like, trying to optimize things and then fly again.
Yeah. Very different style than Blue Origin, whose motto, I don't know if it still is their motto, but at one point their motto was Gradatum Ferociter, which is Latin for slow but with determination or something.
Yeah. Which is why the turtle is one of their mascots.
That's really cute.
Yeah, they have a little
So
turtle on their
they did
heads.
install, as we've mentioned before, a water system on the launch pad because a lot of their problems were that.
Yeah.
They changed the staging system, which is one of the steps where things went bad on the first launch. Anyway, it'll be exciting to see if and how that goes. JWST Annex.
The observatory.
The observatory. I get lost in this big
JWST
house that we
annex
built.
of the observatory.
We do have a large mansion in which we wander now
I
on
know
the podcast.
there was a dartboard at one point. And,
the dartboard. We haven't seen anything on there in a while. I mean, do you want me to talk about this paper, or is that later? Okay. Do we have any other JW hits? It looked at Jupiter. It just looked at Jupiter. I saw a cool headline about that.
Right. It
saw
did
an
look
amazing
at
storm
Jupiter.
on Jupiter.
Saw a big storm on Jupiter.
Yeah. I have something else in the observatory.
Go for it.
Using an Earth-based telescope, scientists have recently discovered the hottest Jupiter-like
Exo-planet.
object. Yeah.
An exoplanet?
Yeah.
Okay.
The hottest one ever. And it's
so
they
hot
said
right
it's
now.
2,000 degrees hotter than the sun.
Oh.
That's so hot.
What? Yeah.
The sun, so the photosphere of the sun is about 5,800 Kelvin.
That's
so
hot.
7,800 Kelvin. So it's brighter than a moderately bright star. The sun is, it's not a super giant, but it's no slouch.
It says it's about as hot as an
its motto.
A-type star.
Hot as an A-type star. Yeah, that tracks.
So it's because it has a day side and a night
What's
side.
it orbiting?
Good question.
Something
a star.
much hotter.
Yeah.
Like an O or a...
Oh, definitely.
And why is it still there?
Yeah.
Oh, I have no
you
idea.
think that would last like
questions.
no time
Boiling
at all.
away.
Yeah.
I mean, it might be. It might be boiling away. It just hasn't finished boiling yet.
Yeah. But we hate things like that. We hate astronomers have an allergic reaction to discovering something that's in the
Transient
process
objects.
of disappearing.
Yeah.
Because then we're like, how come it didn't already disappear?
Why can we observe it now?
Temperature is between about 7,000 and almost 10,000 Kelvin between the day and the night.
That's nuts.
That is nuts. Yeah. Maybe that just hints that like there are just so many of these things. This is
so
a very
many-
common process to take a big planet, slap it in close to a star.
Right. That's one way you get to a very transient event is you have a gajillion of them.
Yeah.
So, okay. I mentioned the dartboard, and I know there's something you want to throw at the dartboard.
What's the dartboard? I don't know what the dartboard is.
You know what dart is?
The dart mission? So we had a dartboard?
Oh, I don't know if I want to do that.
Okay.
It's too
Down quark is...
It's too soon.
Down quark is wound up.
Yeah.
I'm a little wound up, but I don't know if I can be wound up publicly.
Okay.
Is it an archive paper?
It is an archive paper.
Oh, okay.
But it is published. It's just not on the website yet.
Okay.
Interesting.
I know.
Maybe next
Next
episode we'll get her
stay
all
tuned.
fired up.
All right.
Oh,
I
God.
have to say that the basic science of it is something about the satellite of the asteroid, the one that DART hit, right?
No.
Or it's the central one.
It's the system.
It's the system. So these two asteroids that the DART is the double asteroid redirect test or something like that, where we smacked something into the moon of an asteroid. And the paper is just about what's the spectral type of
Essentially. Yeah.
All right. Well, we'll come back to that. But speaking of spectra,
Yeah.
segue.
Yeah, sweet segue. And going back to the observatory. So there was a recent paper that came out in this year, just recently. I don't know. That is, sorry.
I want to get the year nailed down.
Yeah, I think it's right. I think it's maybe just still an archive, but it's accepted for publication.
2022.
It's still an archive, but it's accepted for publication in AppJ letters.
Oh, that's a reference. It's 2020. Sorry,
okay.
everyone.
So this is a new paper about an exoplanet with the name HB. Oh, I don't know where to go.
Hubba.
K2-18b.
Okay.
Very exciting. That kind of sounds like a Star Wars droid.
It does.
So this is a planet that was first detected by Hubble, and there's been debate for years about whether it had water detection in its atmosphere. But it was in the band where it's like hard to actually detect with Hubble. So
this
like
is
maybe there was
transiting
a signature.
exoplanet, or is it a direct imaging thing? Or are we looking at transit spectrum?
I assume it must be transit spectrum because it's observed with yes, it's an absorption spectrum of the atmosphere.
All right. So
with the JW observations.
We're looking at the starlight shining through the atmosphere of the exoplanet, and we're seeing some colors are removed more than other colors, and those colors line up with water.
Perhaps in the Hubble data. So now we have more recent JW data of the same object, and the title of the paper is "Carbon-Bearing Molecules in a Possible Hycean Atmosphere," which Hycean is referred to a class of habitable exoplanets called Hycean worlds that have temperate ocean-covered worlds with H2-rich atmospheres, which is kind of fun.
H2?
Yeah.
Okay. Molecular hydrogen.
So this paper, they posit that there is a detection of methane and carbon dioxide in the atmosphere.
Okay.
They don't say they detect water, but they've done modeling that sort of explains that.
Okay.
And then part of the reason we were talking about this is because there's also a sentence in the abstract, and then they talk about it a little bit in the paper, that there's also a potential signs of dimethyl sulfide, which has been predicted to be an observable biomarker in Hycean worlds. So there's a lot of
dimethyl
sulfide, DMS. So this got picked up because, like, potential life, right?
Yeah.
And
You're convincing me.
I know,
aliens.
Right? Aliens. It must be aliens.
You're an easy sell.
So, like, for all of these,
really
for a lot of these molecules, it's like, okay, but there might be other ways to make it too, and also it's a possible detection. Like, so for the carbon dioxide and the methane, it's a 5 sigma and a 3 sigma. Or a 3 sigma and a 5 sigma confidence, respectively. So they're like pretty certain they see those.
Okay.
For the other stuff, it's a lot lower certainty.
You're talking about spectra of molecules.
Yeah.
I've peered under the hood a few times because my wife does some of that, and it is not pretty.
Well,
it's a lot of guesswork.
I think it's
but when
beautiful.
you've been looking at
It's
that,
not
you've been looking
guesswork.
at reflected spectroscopy of solids, Jim.
Yeah.
Which is different. This is transmission spectroscopy of gases.
Right.
Where the key thing is whether or not you've got sufficient, of course, signal to noise. So how accurately are you measuring the brightness or absorption of each wavelength, but also the spectral resolution. Because if you have very, very good spectral resolution, then you can totally nail it down. in the gas phase, because the molecules are free to rotate and vibrate, and those rotational and vibrational modes are quantized. So you have very specific spectral fingerprints. What your wife does is black magic.
No, it's not.
Or dark gray magic, since it's on asteroids. And you're looking at the solid phase, where the molecules have much fewer degrees of freedom.
But you're still looking at
it's still
atomic signatures.
Yeah, it's still crystal lattices vibrating and emitting or absorbing photons.
Yeah, I'm just saying, I've seen there are these big broad humps, and I'm calling that water, or I'm calling that.
I take offense because we do the same thing.
I know you should. She does as well.
Do you look at solar spectra and see and say that we can say that there are?
Yeah,
for sure.
But in the correct me if I'm wrong, Audrey.
Okay,
but
she will.
Have those.
Oh, I will.
You have molecules in a crystal lattice, and they're vibrating.
Yeah,
but
exactly.
They're not those vibrational frequencies. Are they quantized? And do you have unique? Unique spectral fingerprints. At very fine spectral resolution for those molecules.
No.
Yes and no.
No.
There are, but there are because.
It depends.
There are multiple.
It depends on other things.
It depends on other things
that you cannot control for, such as the particle sizes and things like that.
Well, no, you can control for those. You just
don't know them.
Right. That's why you have to do laboratory measurements of a whole bunch of different particle sizes and all of that, and then get a good database, and then you can.
And then things like, okay, there's this humpish thing here at 3 microns or something like that, and then they do. They do these code things where you let's plug in so much of this thing and so much of that thing and so much of that thing, and they can get 27 different things that all fit the same damn thing, and then they decide which one they want. And
yeah, that's called a bad scientist. You're describing bad science.
No. I'm not saying that Zoe, my wife, does that. I'm just saying that that's what I've seen that community do.
With this data from JWST, there are questions about sometimes about the cleanliness of the data, right? Yeah. Or about how easy it is to detect. And with this data, they do models to fit the spectra. So they do models to fit the spectra. You're looking at the public image, right?
Yes.
Yeah. There's also lots of figures in the paper that are
and those are model
different
plots.
Squiggle lines that are mixtures of model plots and data plots.
Yeah.
And so they can fit. So they look at the spectra. They look and see where there's different lines for CH4, for CO2, and for other things. But then another big thing they do with this paper is they did modeling of how you would get that atmosphere. And so this is one of those ways that they say yes, it's this Hycean planet, is because they think the reason they're detecting these things in the atmosphere is because it is an ocean world, basically. So it has a big ocean on the surface, and so part of the reason you don't get water.
I love that, by the way.
Ocean world?
Yeah.
You can have the postman there.
A postman?
Really
Kevin
bad
Costner,
Waterworld movie. Yeah.
Cool.
I enjoyed the hell out of that
Postman
movie.
is a different movie, but
I know.
Anyway, yeah.
Never saw it.
Cross. Anyway, that was bad. So one of the reasons you might not get a detection of water in the atmosphere is because the JW observations probe the upper parts of the atmosphere. You're just getting the upper parts, and so that there wouldn't be water up there because it's being mixed in the lower layers of the atmosphere.
So you might see
CO2 and methane, but the fact that you see CO2 and methane is really interesting because they're basically end states. One is you get from reducing stuff, one you get from oxidizing stuff, and so it probably indicates that there's a lot of chemical mixing and not biosignatures, but chemical reactions and things like that.
Life.
And so maybe life.
I'm in.
So that means that one molecule is being made by reducing, and then there has to be a different mechanism to explain this highly oxidized.
You have to have chemical reactions or mixing and things like that.
You got to think about
you get both of those things in the same
full atmospheric chemistry and dynamics are going on as well. The data, are the best in the world.
Yep.
They're also kind of noisy.
Yeah.
They do a decent job of fitting a model, or they've come up with a model that does a decent job of fitting the data, I should say. However, there are, several data points that are outside the error bars away from the model. So the model is, not perfect.
To be fair to these folks, the fact that they can do this at all is preposterous. The fact that you can get an absorption spectrum through an atmosphere of an exoplanet that you can't possibly even see or anything. I mean,
I know.
It's they're really data geniuses.
Yeah. I mean, they've got a very good fit here. Their reduced chi-squared for our statistics nerds out there is 1.08, which is nice.
That's pretty.
It's a very good number.
Yeah.
In any event, that's cool, and so there are aliens there, right? We've confirmed it.
Yeah.
Aliens!
So the takeaway from this is aliens found.
No,
and
I think,
and this data isn't publicly available yet, so it's some of the JW data that's like they're still in the proprietary period or whatever for these authors. So once it becomes publicly available, lots more folks will analyze it and do models and stuff like that.
And the normal proprietary period is about a year, so just wait a year.
But I think that it's...
Or less.
Yeah.
I think the real takeaway is this is where I'm putting my money for how we will detect alien life if we ever do.
For sure.
This exact kind of measurement.
Yeah, whether it's DMS or some other molecule. There's a lot of molecules out there that like are primarily produced by biotic methods, mechanisms.
So I think that's what we're going to have. All right, let me give you your trivia question, and then Jim's going to talk to us about baryons.
Woo!
Okay, so our trivia question is a little bit meta on this episode.
Okay.
Like Facebook?
No.
Okay, good.
About the podcast.
Oh.
So the Addie remembers that the podcast got its start from our coffee runs, where in the mid-afternoon here at UCF, a group of us would go for a little break and
break from the air conditioning through the heat
to a coffee shop. And since I don't drink coffee, when we would text each other, instead of saying coffee, we came up with Walkabout, because we would go on a walk across the campus, and Addie and earlier AstroQuarks Tracy Becker and Ashley Kehoe and I would have fun conversations that are not too dissimilar from the conversation you've just been listening to. In other words, slightly annoying and very ridiculous. But on a range of topics. And so
the slightly annoying and very ridiculous
podcast. So that's where we came up with the name Walkabout the Galaxy for our podcast, which is listened to all over the world.
Indeed. Perhaps on your walkabout, you're listening to it.
And
right now.
Do you know what the word walkabout means?
I do.
Because it's not really in the American vernacular.
No.
If you look in the Oxford English Dictionary, it means when a famous person walks around a public space and talks to the public about some topics. I always associate it with like hiking in the Australian outback.
Yeah, I learned everything from Crocodile Dundee.
There you go. Well, that's the lead-in to this trivia.
Okay.
Which is, which country in the world is our podcast the most popular, measured by downloads per capita?
Downloads per capita.
Downloads per person in that country. I used data from 2023. So up to October 20th, 2023, in which country has the most downloads of Walkabout the Galaxy per capita? I'll have some follow-on questions after you guess there, but let's talk about cosmology.
I heard that I was not here last episode of Walkabout the Galaxy for our regular listeners, and I heard that you punks talked about fast radio bursts without me.
Always.
Yeah, we were like, oh, Jim's not going to be here? Perfect.
That's fine, because they're not really my thing anyway, but we're going to do it again. We're going to talk about but we're not really going to. I don't really care about the specific fast radio bursts. I saw an article about a specific one, and it was like the most distant one yet seen. It's something like 8 billion light years away. They found one. That's cool, but that's not the interesting part of the story from my perspective.
What we talked about last episode, and it's sort of just as a reminder for what an FRB, fast radio burst, is. It's a very high energy emission that has very short duration typically. We pick up in radio waves, and what we talked about last time was a very cool sort of statistical analysis of FRB data that suggested that they may be produced by starquakes on neutron stars. So we were excited also not really about the FRBs, but about the structure of neutron stars and whether they've got a crust that can quake.
Right. That was so cool.
There you go. It's the cool astronomy podcast.
Yeah. That is very cool.
Why can't this episode be more like that one?
Now
so
it's going to be.
This is another cool aspect of fast radio bursts. That is, again, I don't care about the burst itself really, and this time I don't care how it is produced, which is what you were talking about last time. But a cool thing is what they can tell us about the universe between us and them.
Ooh.
So one cool thing about them is they're ridiculously bright and originate from very, very far away, which means they're like a...
We can do occultations.
They're a beacon.
Yeah, they're a beacon that tells us about...
An occultation of the universe.
Yeah, it tells us about all the stuff between us and the originator of that. Yeah. And it's super useful because... And this is something I don't think people have an appreciation for, but
make us
you look out in the universe and you see all this shit.
Oh, he's going to make us appreciate it.
You're going to appreciate the hell out of this. You see all this stuff. You see stars, right, formed into galaxies, and you can see hot gas in the galaxies and all that.
Hot gas.
And all that stuff is made out of, we call that baryonic matter, right? It's made out of protons and neutrons and electrons, all the normal stuff that we're familiar with. But it turns out that we are pretty sure that there are drastically more baryons in the universe than we can account for with all of that stuff.
No.
Like a factor of 2 or 3 more.
Why is that? Why are we so sure about that? I thought.
Is this a dark matter thing?
No, it's not a dark matter thing. So
is it a dark energy thing?
No, it's not a dark energy thing. It's just that we can.
That's all I can think of.
By looking at.
Is it a dark magic thing?
No, it's not a dark magic thing. I mean,
so it's
dark
not Spectra.
matter. There's much more dark matter out there than there is regular matter. But even regular matter, we're only seeing a small part of even the regular matter.
Right. That's what you
Where
said.
is it hiding?
I'm trying to. Yeah. How is it hiding?
The way it's hiding is it's mostly hydrogen that's out there in between the galaxies, but like 30 atoms per liter or something like that, like some ridiculous vacuum.
So vacuum isn't empty; it's full of hydrogen.
It's full of hydrogen.
Do we know it's there from emission or from models?
So we originally guess it's there from looking at cosmology, saying if we look at the early universe and we look at the conditions there, we say
made-up models.
Made-up models. This is some of the really gorgeous stuff for the nerds who like the early universe. Like we can't see in the universe past about 300,000 years after the Big Bang. It's opaque before that, but we can still say some sensible things about the first 3 minutes of the universe, because that's when you make
all the protons and stuff.
Well, you
make hydrogen.
You make deuterium. You make helium.
I kept trying to guess the right answer, and I kept missing.
You're almost there. You make the heavier things. You start with protons and neutrons, and you smash them together to make deuterium, which is just a proton and a neutron, and helium, and little bits of lithium and maybe beryllium and things like that.
Okay.
The ratios of those, like how much deuterium versus hydrogen versus helium, is determined by how much total stuff there is in the universe.
Okay.
So you can figure out how much stuff there is. We only see
in order to get 3/4 hydrogen, 1/4 helium, which is basically what there is, you have to have more hydrogen than what we see in stars and galaxies.
Right.
Why couldn't you just have said that, Jim?
He had to explain it.
But here is a final way. So that's the guess, but you have to be sure. To be sure, you have to be able to see it. But it's really hard to see because the gas is so diffuse that you're not going to see like absorption lines and things like that. Okay. So that's why you can't use like a quasar, really bright quasar, and like see absorption lines through that quasar or something like that, because you're not going to capture that stuff.
Okay.
But an FRB is a bunch of radio waves.
True.
And radio waves are longer frequency things, and so you get dispersion of the radio waves.
Longer wavelength?
Longer wavelengths than visible light.
You said longer frequency.
Did I say longer frequency?
Yeah.
I'm a moron. Don't listen to me. It's longer wavelengths.
We usually don't say longer frequency.
No, I was in my head. I was saying wavelength.
Okay.
Longer
wavelengths. And anyway, even in a fairly diffuse gas, you get dispersion. That is, the longer wavelength radio waves move more slowly through that medium. Right. Dispersion is where different wavelengths of light travel at slightly different speeds in a medium. But and so this is a medium. It's a very diffuse medium, but it's a medium. So the long wave. So that means the very sharp blurp of the FRB gets spread out over time. Because
this is why a prism works, right?
It's exactly why a prism works. Exactly. Because the blue light travels at a different speed than the red light through the glass.
Right.
And so that means the light spreads out. And here, it's the radio wave that's a radio blurp from the FRB that's spreading out. The longer wavelength stuff is traveling more slowly, and so it gets to you later. And so it's...
So we sort of see a tone, or we hear a tone in the FRB radio burst.
It's just this long spread out thing instead of a pop.
Okay.
And that's basically a measure of how many, ionized hydrogen atoms there are between us and...
And how many are there? Wait a minute, that should have been the trivia.
How many are there?
Well, not many, but just the perfect amount to match our guesses from that nucleosynthesis business.
So it confirms.
It confirms that we were right.
And now I appreciate...
Go on, your bad selves, cosmologists.
The Furby stuff. The... Baryons. More.
Do you?
Yeah. We now know how many baryons there are.
I do.
There's a certain tone.
I don't know why you aren't believing me.
Yeah.
I really do.
All right. Well done.
Plus, you sound smart if you say words like baryon.
Okay. So this was not... Baryon. This is the first time this particular...
So this, I won't say in 2023, but over 2020 was the first time this was suggested as a way to do this. And but you need to really do a good job, you need a bunch of these...
you need a bunch of bright things far away, right. and so pick those up.
We kind of just now got to the point where we have enough of these that we can substantially measure it.
Most of these FRBs are not repeating, so you can't plan
and
just go out and say, oh, okay, I'm just going to go observe 20 FRBs at 8 billion light years away and make this measurement.
Right. And also, we're getting better at identifying where the FRBs come from. You have to have these big arrays of radio telescopes to be able to locate on the sky where your burst of radio light came from, and we now have those things, those big arrays that are looking for these things. And
cool.
All
right.
Okay.
Where are we most popular?
Per capita.
It's
going to be some
That's fair.
small...
That's a fair way to do it.
Yeah, I was just clarifying.
And I should clarify that I did not include tiny countries. Like if there's one listener in Vatican City.
Yeah.
That's where we would be most popular per capita, I'm pretty sure.
So it has to be at least like 5 listeners.
Yeah.
The population of the country is, I think, the smallest.
We probably do have a listener in the Vatican.
That's true. There's an observatory.
5 million, I think, is about as low as I went in terms of country population. So things like little island countries I didn't look at.
Not that you're not important listeners there. Thank you very much.
I want to see this
Thanks to listeners
geographic data.
You can look at it on our stars repository thing.
Oh, okay.
Yeah.
It's probably not the U.S.
I feel like it's not the U.S. because that'd be too easy.
Yeah, otherwise it wouldn't be a fun question.
He will sometimes mess with you like that, though. He plays psychological games. This Josh does.
Yeah. What's your thought, Jim?
Canada.
I was gonna say Canada. Maybe the UK.
Addie says UK.
I'm gonna go with Australia.
I like it.
Oh, or South Africa.
Ooh.
Oh.
I know.
Do Australia.
Austrafrica.
You got to make a decision there.
Oh, that means one of them's right.
No.
Oh, okay, I guess I'll go with Australia. But listeners know that I also think it's South Africa.
Okay. Well, you just weakened your victory because it is Australia.
Oh.
That was a good answer.
Australia, very closely followed by second place.
South Africa.
Not South Africa.
The UK.
Not any of the ones
the United
that you mentioned.
States.
No.
Ireland. Spain.
Ireland.
Really?
Is in second place. Your next follow-up question is, in what place is the United States in this particular ranking?
Oh. 7th.
4th.
5th.
Audrey's on a roll.
Oh,
yeah. Our top are Australia, Ireland, very close, and New Zealand. Also, all those three very close. Shout out to you guys. Thank you so much.
Thanks, everyone.
Followed by the U.S.
We really need to do a road tour.
We sure do.
And visit all of our faithful listeners.
Mm-hmm. Final follow-up is, in what country where English is not the official language are we the most popular?
Oh, wow. I like that.
Technically the U.S.
Spain.
It's not an official language, that's true. But you know what I mean, excluding the U.S.
The U.S. has no official language.
Oh, really?
Yeah.
That's correct.
Well, gerbil, gerbil, gerbil.
Portugal.
Spain, Portugal.
Germany.
That's what Amory guessed also. No, Denmark.
Oh.
Denmark.
Okay.
Yeah.
Thanks.
Denmark, followed by Canada and the UK. In other words,
okay.
we're more popular per capita in Denmark than in Canada or the UK.
Okay.
Yeah.
Thanks, everyone.
I also want to say that like the term walkabout technically comes from indigenous populations in Australia, and it was probably
so the OED,
co-opted.
the Oxford English Dictionary term.
Yes.
That surprised me when I saw that.
Yeah.
OED
Well,
definition.
colonialism often
Like,
surprises people.
Yeah,
so.
yeah. the people being colonized are very surprised, I think. They're like,
Not
wait a
usually in a
minute,
good way.
where the hell did you guys come from?
Yeah. But anyway, so it is an interesting term for like.
Yeah. Bermuda might have come out on top if I had not excluded tiny countries. But
Interesting.
The number of
Definitely do a
downloads,
roadshow there.
Yeah.
the number of downloads in 2023 is consistent with a single listener listening to all of our episodes this year.
I hope they get thanks at the end of the
I would
show.
spend
Thanks,
instead
listener
of
in Bermuda.
taking a balloon or a rocket, I would go to Bermuda to visit our listener.
Yeah. Okay. Well, it may have felt like a walkabout the Australian outback. It was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe.
Be sure to follow us on Facebook and Instagram to get all of our updates.
Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts.
Our theme music was composed by Richard Jurisic. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Australia and Bermuda and around the world. Stay safe. I'm Josh Caldwell.
I'm Maddie Dove.
I'm Jim Cooney.
And I'm Audrey Martin.
We're the Astroquark signing off until the next episode of Walkabout the Galaxy. Blurp.
Blurp. This is the new.